let's take a glance at homework number 3, but page 1, because we were only doing page 1. As a quick reminder, again, I know this was probably easy cheesy. Once you started doing this, it is. But we need to go ahead in our mind, get prepped and ready, so that way we can go ahead and get to our SOHCAHTOA information that we need to get to. If you took a glance at the next following homework, that's part of this SOHCAHTOA. We need to get to that. First thing is, I mentioned, this is how I personally label the opposite, the adjacent, and the hypotenuse leg. If you learned it a different way, then do it your way. But I go to the right triangle, I draw an arrow, and that arrow touches the hypotenuse leg. So I go to the right triangle, and I connect that arrow to the other side, and every single time I do that, it touches, or the arrow points to what my hypotenuse leg is. It may not mean or look like it's important now, but believe me, after our notes today, it's going to be super important to do this. Then I find the theta. I told you yesterday, and I'm going to say it again, the theta will be not given to you like a pretty little triangle. No, I give it to you in words. So we need to be able to read the words, create our triangle, and label it correctly. So the theta always attaches to the 90-degree angle. That leg is always my adjacent leg. So if you find the theta, get that leg that touches the 90-degree angle, and that is always going to be your adjacent leg. So that hopefully helps you out. It's like a little visualization for me, and this is how, when we do our math problems, I label them the same exact way. And then the other leg that's left over is the opposite leg. So hopefully that's what you got for your homework. I think it was probably a pretty easy homework. Then we get over here, and obviously we have 3 legs of a right triangle. And from those 3 legs, they're not asking us to label the adjacent, opposite, or the hypotenuse. Okay, they actually gave us the numbers. Here they are, here they are, here they are. And they gave us units, thank goodness. Now they're asking us to find the missing leg. This is like 5th grade, 6th grade math, right? But again though, I do start all of my physics units with basic level, just so to make sure that we're all on the same page. So let me go ahead and get my calculator. And so for this situation, we're going to a squared plus b squared equals c squared, right? So our equation is going to be the Pythagorean equation equals c squared. And so for that situation over here, it would be 6 squared plus 3 squared equals c squared. And thank goodness, when you come over here and form your right triangle, you can see that that is your hypotenuse leg, which is your c squared. So hopefully that we did notice that. So hopefully you got 36 plus 9 is 45, but I'm sure all of you already know that this is a c square, so we've got to square root it. And then in this situation, when I hit square root of 45, I got, and this is your hypotenuse, this should be your longest leg. I got this leg right here to be 7.483. Maybe you put 7.5. It is okay. I do not care how many digits you go out. But what I do care is that you put your units to be centimeters. So if you got 7.5, that is amazing. Yes, sir.
I got 6.7.
Oh, did I screw it up? I didn't agree. 45. Okay. A 45. 6.7. Dang it. Good job, Soto. What's wrong with you? Are you wigging out? Are you spazzing out over there? What are you doing with your hands? Let's keep your hands. Why don't you sit on your hands? Because, yeah, whatever this business is, let's Yeah. Golly, Soto. Just because you were right and I was wrong, and now you're like 6.7, Miss Munson. I wish this thing was recording you over there. All right, 6.7 centimeters. And he is happy. Mr. Houston, you okay? You good? Okay. Woo. Man, I made a mistake. Obviously, it was huge because he's still laughing over there. You good? You're good? Oh, it's all right. You're a little off. Oh, you're off today. All right, here we go. 144 for the 12 squared plus the 25. See, this is why you've got to keep an eye because I might screw it up. 169, square root it, double check me because I might mess it up, equals double check 13 centimeters. Okay. All right, here we go. Next one, 2 meters. Oh, they gave us meters. This is actually my right triangle, so that's my, whoa, that's my hypotenuse, yeah. Say it again.
Why is it 2 and supposed to be along the side?
Oh, good call on that one. Soda, why didn't you say something on here on this screw up I did? Good call. This is the right triangle, and remember when the right triangle goes across and touches it, then that's your hypotenuse, and your hypotenuse is supposed to be the biggest leg. There is no way that it can be 2.
I just did it the other way
Just to find it?
Just to see the other side.
Okay, so, alrighty, I got you. So 2 squared plus 5 squared equals C squared, and we all know, and we're saying this out loud, Miss Munson messed up, but I'm going to fix this before next year. I'll make it a 12 for next year. How about that? That's an easy fix. But, okay, Soda, what did you get then? Did you do it this way? No, you did it for the other way, huh?
Yeah, I put 5
as the C. Oh, and I apologize because the 2 would legit be the C square because that's the right triangle. And remember, the other side that it touches is the hypotenuse. Well, Logan, what'd you get on this side then?
I got,
if you did it this way.
5.4.
5.4 meters. So forgive me for that mistake. Good call on it. We'll have to fix it for next year. The next one though is not a mistake, I will say. This one's a pretty good one right here. There's a ladder leaning against the house. It's on the side of the house. So visualize, and I'm going to come over here and draw this house. And we have a ladder. On the side of the house. It's just leaning up against the side of the house. Now, it says here that a ladder is leaning against the side of a 10-meter house. So for this situation, they gave me 10-meter house, or that 10 meter is referring to this side of the house. So I'm going to go ahead and label that 10 meters. Okay, now my drawings are never proportional, okay, so I apologize. But the ladder, it says here, the ladder leg is 3 meters away from the house. This leg right here is 3 meters away from the house. It looks like we just made a right triangle. Heck yeah, because Pythagoras super easy cheesy, Miss Munson. I know. I like that also. So if this is my right angle and I do my arrow, this is my hypotenuse leg. So a squared plus b squared equals c squared. A squared plus b squared equals c squared. Or I'm going to call it 10 squared plus 3 squared. Again, it doesn't matter which situation. Or 100 plus 9 equals 109. But this is square rooted, so or squared, so I'm going to square root it. And I do not know 109 off the top of my head, square root it. So I'm going to come over here and double check me. Hopefully you got something similar to this as 10.44. This was meters, so my answer is in meters. Hopefully that sounds about right. I did my picture, and believe me, we're gonna need to start doing pictures pretty soon. Next one though, it says here, first draw a picture. Oh, good. Then show your work, okay. From a horizontal distance of 80 meters, the angle of elevation to the top of a flagpole is 18 degrees. Calculate the height of this flagpole. Now, we haven't necessarily done practice problems like this, but I did give you the equations. If some of you have already done SOHCAHTOA, then this may have been pretty doable, hopefully. But if you didn't, at least you tried by drawing out the picture and labeling it. So let's do that part at least. You personally could have drew the flagpole over here, or you could have drew it over here. In this situation, just like you had in math class, when you talked about triangles, it doesn't matter if it's triangles facing this way or if it's this way. It's still the same triangle, okay? So I'm going to come over here and I'm going to draw my flagpole. Again, not proportional. There. Okay. So here's my flagpole. I put a flag on it, and it says from a horizontal distance of 80 meters. Okay? Horizontal is like this. Horizontal distance of 80 meters. I really like this question because hopefully you tried it at least. I'm hoping. At least the drawing out. And this is what our math is going to look like. It says the angle of elevation to the top of the flagpole, meaning if you were standing over here, the angle of elevation to the top of the flagpole, oh, there goes my vector. This angle right here is 18 degrees. Okay, this is the math that we're going to get to. The angle of elevation to look at the top of the flagpole is 18 degrees from the ground. First thing is, I see this, and number one, I'm hoping you had this type of math prior. If not, no problem. I see a right triangle. And when I see this right triangle and I draw my arrow, this is my hypotenuse leg. This is my theta. Remember how I told you we're not going to give you thetas? We're going to give you word problems, and you have to figure out the theta. If this is my theta and this is my right triangle, then that must be my adjacent leg. And who is left over? My opposite leg. Ah. Okay, I did not think this was going to be easy. Maybe you ChatGPT, Googled it and searched it or YouTubed it, but this is the type of stuff we're getting to. Okay, so let's take a glance and let's keep looking at this. Because yes, this is what we're doing in our notes today. Calculate the height of the flagpole, meaning what is this height right here in meters? Okay. So if I have the A and I have a theta and I'm looking for the O, yes, this is notes that we have not necessarily covered, but we are getting to. Here are my equations. I have the O that I'm looking for and the A. Which equation has the O and the A? Oh, this one right here, tan. The tan of the theta equals the opposite divided by the adjacent. Or the tan of the theta equals the opposite over the adjacent leg. And the opposite leg is what I'm looking for. I understand it was difficult, but we need to go ahead and fill it in because we have these notes in just a moment. So let's get prepped and ready for today's notes. Let's write in our information. That would be tan of 18 degrees. And remember, I had taught you earlier yesterday, how do I do that? I need to make sure I'm in degree mode. So if I was you, I would probably go double check my calculator. Am I in degree mode? Oh, I am. I'm good. I'm going to hit clear. Equals the opposite leg, I do not know, and the adjacent leg is right here of 80 degrees. Okay, now we can go ahead and solve for this. And this is the next step of our process of getting through SOHCAHTOA. Multiply this side by 80, cancel. Multiply this side by 80. I'm going to first come over here, me, and I'm going to say the tan of 18 degrees, oops.
You put 80 in tangent.
Oh, can you?
Yeah. No, you put 80, then click tangent, and then you do 18.
Oh, I could. You're right. I see what you're saying. I just like to do it step by step. It works either way. I agree. Either way, it works. So I'm going to go ahead and this is 0.325. I'm going to times that by 80, just in case if you wanted to see step by step. When I multiply those two numbers, my opposite leg or the height of the flagpole is 25.99. Wait a minute. If I'm looking for this leg and this leg is in meters, then that is in meters. That is the correct answer. So I'm hoping, fingers crossed, you've got these math skills. If not, no problem at all. Mr. Houston, what is the sign of 25, sir? 4, 2, 3. Kim, you agree? Okay. Miss Steva, what's the cosine of 53 degrees? 60. Do you agree, Mr. Houston? Mr. Soto, what is the tan of 34? Is it really, or is it that? Okay, seriously, like you're sus. That doesn't even, how that magically, the two questions are the, get out of my room. I'm done. No, I'm kidding. I don't know. You're just, today's your day, like for real. This is weird. I mean, I know you're not old enough to play the lotto, but you need to go play the lotto, like something. You are on fire today. Wow. Okay, so here's where we left off in our notes. Let's go ahead and turn the page so that way this is what I was showing you on the homework. Okay, so let's take a glance so that way we can move on to the next step, because after this we actually take it to another step on the next page of homework, okay? So here's what we need to do. We need to be able to label our triangle just like we did prior. So when I draw my arrow, this is my hypotenuse. Oh, look, they were kind enough to give me my theta. So my theta and my right angle is always the adjacent leg. And then left over is your opposite leg. Well, what am I looking for? When I look at this homework, or notes, forgive me, they have a letter B over here. So that means that I'm looking for the O. Now, the sine equals the opposite over the hypotenuse. The cosine equals the adjacent leg over the hypotenuse. And the tan equals the opposite over the adjacent. This is your three equations you're going to use, SOHCAHTOA. So I don't have to turn to the previous page. You could if you want to. Now, what I am looking for is I'm looking for this leg right here. And I have this leg. That means that my equation needs to have H and O. Who has H and O? The sine. So the sine of the theta equals the opposite divided by the hypotenuse. Or, let's fill in our blanks. The sine of 35 degrees equals, I do not know the opposite, divided by 16 centimeters. And my answer is going to be in centimeters. Ready? I need to algebraically get O by itself. So multiply by 16 to cancel, and multiply this by 16. Hopefully you see why those orders of operations were so crucial. Let's go ahead. I'm just going to do this step by step. 16 times when I got this sign of 35.574. Multiply that by 16. I end up with an answer of 9.18 centimeters. Not too bad. Hopefully easy cheesy, I'm hoping. I'm going to skip over. I'll let you do B. Let's look over at letter C. C. On C, again, I need to label my triangle. So let's do that. Let's label this triangle over here. Oops. Here's my right angle. Draw an arrow. That's my hypotenuse. That is so sweet that they gave me the theta, but when I connect that leg to the 90 degrees, that is my adjacent leg. Left over is my opposite leg. They gave me the hypotenuse leg, and I'm looking for the opposite leg. Oh, snap. It looks like it's the same equation. That's all right. The O and H is the sine equation. So the sine of theta equals the O over the H, or the sine of 23 degrees equals, I don't have my O leg, I do have the H of 38. Again, that's in centimeters, so my answer must be in centimeters. So the sine of 23 degrees, I'm just going to do this step by step. That is 0.391, but I need to multiply by 38 to cancel. Multiply all of this by 38. This comes out to 14.85 centimeters. Double check my answer. Which looks like that's a good number, because if that's my hypotenuse, unlike the homework that I made and I messed up, my hypotenuse better be bigger than my opposite leg. 14 is smaller than 38, so that looks pretty good. Let's practice a practice problem, okay? I'm going to scroll down to over here to this section. It says that an archaeologist climbs this pyramid. Oh, we're back to the pyramids again. Now, if the pyramid's height is 140 meters, okay, and its width is 230, what is the magnitude and direction of the archaeologist's displacement? This is a good question. So let's go ahead and let's draw this out. I've got a pyramid. Here it is. Now, you want to go and find out a couple of things. Number one, I'm going to underline it, magnitude and direction of the archaeologist's displacement. So this archaeologist is down here at the bottom of this desert and wants to walk up to the top of the pyramid. Let's look. I like to draw those vector arrows in dashes because that helps me identify what I'm looking for. So I'm gonna, I'm trying to figure out two things, because you can read it and it uses the word and, magnitude and direction. So I need two answers. Okay, now first thing is, rather than me try to take up time and trick you, I'm pretty sure I don't have to trick you anymore. This width is 230, but we know now that we are going to go ahead and call it 115, 115, and cut the base in half, right? No need, I'm not going to trick you. The height is 140 meters. So this is 140 meters. We need to start doing our drawings to help us out. When I cut this base in half, I was able to produce and form a right triangle. If I draw my arrow to the other side, that is my hypotenuse. But here is the tricky part. Remember how I told you, I am not going to give you the theta. You need to find the theta on your own. This is where you need to pay attention. How do I know, Miss Munson, if this is my right triangle right here on the board, then this one or this one is my theta. I hope you all agree with that. That this is my right triangle, I know this theta, 90 degrees. But if you're the archaeologist and you want to find the magnitude and direction, aren't you going to walk like this? Do you see how I draw my arrows with dashes? The bottom of my arrow will always be my theta. Let me say it one more time. In physics, when you're drawing vector arrows, the bottom of that vector arrow is your theta. I like to draw my vector arrows that I'm looking for in dashes to help me identify this is the vector that I'm talking about. That is the vector that I need. They have magnitude. What does the word magnitude in physics mean? Number. What does the word direction in physics mean? That word direction in physics means theta. Let's go ahead and let's label that because you're going to go home and you might forget. One more time. Magnitude means number, but don't forget all numbers must have an SI unit. In physics, when we say direction, we mean theta. Okay? One more time. I need to find the magnitude and the theta for the archaeologist who is going to climb this pyramid. So when they climb up here, I drew out this is the direction they're going to go. Here is my vector. That means that this is my unknown theta, and this is my unknown leg, or the magnitude. The leg of that vector arrow, or the leg of that triangle, the hypotenuse leg, is my unknown. The leg right here, or the theta, is my unknown. Okay? Now, since I have two legs, I have this leg and this leg, the opposite and adjacent. Couldn't I just Pythagoras to find the hypotenuse? C squared? That's easy. But if I need a theta involved, I have to SOHCAHTOA. This is a two-step problem. Okay? So let's go ahead and let's do this because this is going to be what your next homework is. Step number 1, let's knock out the easy part, which would be, what is this hypotenuse? A squared plus B squared equals C squared. Well, obviously, since I labeled this, and if this is my theta, and this is my right angle, then this is my adjacent leg, and that is my opposite leg. This is why we need to know how to label a right triangle. Let's go ahead and plug in. 115 squared plus 140 squared equals C squared. 115, oops. That comes out to 13225. Double check me though, please. I'm going to add those two numbers together. Again, I am doing it step by step. I know that I cannot leave this. I have to square root it. Please check my answer. I got 181.18, wait a minute, meters. And that is my hypotenuse, so it better be the biggest leg. I'm just going to put a little line. This is part 1. I'm going to come over here, so when you go home over the weekend and I'm not sitting there to answer your questions, then you can look at this. This is considered to be the magnitude portion. That is your magnitude. That is a number. Remember, magnitude is number. And don't forget, we put a unit behind all numbers. So the magnitude portion is done. Check. Let's find the direction. One more time. In physics, direction is considered to be the theta. So I need to figure that out. Well, to figure that out, I'm going to have to SOHCAHTOA. So I'm going to come over here and I'm going to say part 2 is SOHCAHTOA. SOHCAHTOA. Now, which portion am I going to use? The cool thing is that now that I have this leg of 181.18 meters, I can pick any portion. I can pick the SO, the CA, or the TOA because I have all 3 legs. So, Soto, give me one. Which one? So, CA, or TOA? So. He's on fire right now, so I'm going with his so. The sine of the theta equals the opposite leg over the hypotenuse leg.
Would it be better to use one that doesn't have an estimated number in it, though?
It don't matter.
Okay.
It doesn't matter. Or we can just change this to 118, round it. If you want, so yeah, it's okay. Either one, either way. So the sine of the, wait a minute, do we know the theta? No. Equals O 140 over H 181 point, I'm gonna write the 0.18. I'm gonna leave it as is. I'm not gonna round. Okay, so, 140 divided by 181.18, it's going to come out to a decimal. 0.773. Degrees. Say it again?
77 degrees.
Well, but that says 0.77.
I don't know.
Hmm?
I don't know. Right.
Out of 1? Could that be Logan over here? Could that be, first thing, my question to you is, could that be the right answer? Could that? No. Okay, so I like that because you were like, Logan, this sounds like, well, is it 77 degrees? Now, it is a degree. And it's not 77 degrees, and there's no way possible it could be 0.77 degrees. And the reason for that is, stop for a moment, isn't this 90 degrees? Half of 90 is 45, half of 45 is whatever, 22 point something, and less than that is less, half of that, and then half of that. 0.77 degrees wouldn't even be, what, can you imagine? Is there any way mathematically this could be 0.77 and he walks up to the top of a pyramid? No. So we have to do the inverse. That's what Logan over there was going to say. So we have to inverse it. What, Miss Munson? What's the opposite of square? Square root. What's the opposite of sine? The inverse of sine. What's the opposite of cosine? The inverse of cosine. What's the opposite of tan? The inverse of tan. So again, like I said, I'm not sure where everybody's at with their math, so I like this problem, so we can practice it together. Miss Munson, I don't have a clue what you mean what the opposite is. Do you see over here that sine -1? Hit second key, sine -1, or sine, do you see that little -1 at the top? That's the inverse. Go ahead and type in 0.773 and 50.62 degrees. That is my direction. The theta equals 50.62, and take a glance real quick in just a moment. This is the SI unit, degrees. If you don't have it, -2 points. That is the actual SI unit, degrees. And so we call this portion the direction. Whew. That was a lot. That was a lot of work, Miss Munson. I know. We're about to take it to another step even harder. Got it? We got to practice. We got to practice. But before we practice, I need to take us to another page. Let me double check our homework. Homework number 3, homework number 4. Yeah. No. Homework number 4 is going to be tough. Alrighty. That's okay. Practice it again. Turn to the hummingbird. Okay, let's go to the hummingbird. We're gonna change up homeworks a little bit. I was hoping we can get through notes a little bit faster. Not a problem. We'll just push homeworks back a little bit. So give me a moment and we'll do that. We need to practice though a little bit more. Let's get to this hummingbird. The hummingbird is flying. Okay, gotcha, Miss Munson. It's flying. Oh, it's such a cute hummingbird. So I'm gonna draw it out. Let's draw out this hummingbird flying. It's got a long little beak. It's got little feathers. There's my hummingbird. All right. A hummingbird, it flies 1.2 meters along a straight path in the sky. Okay? 1.2 meters. Straight path in the sky. Upon spotting a flower below, the hummingbird drops directly downward 1.4 meters to hover in front of this flower. So there's like this flower, it tells me here on the ground. You don't have to draw it out. I'm gonna, just so I can visualize it. I want to visualize what it's telling me. And the hummingbird literally, look at this, drops straight down 1.4 meters. I know it says hover in front of the flower. I guess, I don't know, my drawing's off. Remember, it's not always proportional. What is the hummingbird's total displacement? What I want to tell you is that the word displacement or total displacement means magnitude and direction. That's what angle is, right? Theta. I am going to get to the point where I will no longer put parentheses. I will just use the word displacement. So displacement, isn't displacement a straight line? Like this? From the start to the end is what displacement is. Do you see how all of this stuff that we've been learning is coming together now? It's starting to merge together. So what is the displacement? And displacement is a vector quantity, which means magnitude and direction in physics means a theta. So that means that I'm looking for this leg and I'm looking for this theta. How do you know, Miss Munson, that that's the right theta? The theta that's at the end of the arrow is my unknown theta. That is always the theta I'm talking about in physics. Okay, step 1, let's go back to what we learned about labeling the triangle. This side is my hypotenuse, this is my theta, and this is my right angle, so this has to be my adjacent, and this is my opposite leg. Let's practice this problem, and then we'll be done for a lecture today. Now, we've got an A and an O. We need to find the theta. We need to find the other leg. Now, I agree, like last problem, where Soto said, hey, let's SOHCAHTOA it and let's use the sign. But you know what? We don't have to Pythagorean and then SOHCAHTOA. You could choose to do SOHCAHTOA twice. So let's go ahead, and that's what I'm going to do. I'm going to start off this time a little differently. I'm actually going to look for this theta first. So I'm going to say, hey, I have the A and the O. So I'm going to SOHCAHTOA. I have the A and the O, which is the tan. So the tan of the theta equals the opposite over adjacent. Or the tan of, oh snap, I don't know it, but that's okay. I have the opposite of 1.4, the adjacent of 1.2. So 1.4, double check my math, 1.2 equals the tan of the theta of 1.167. Is that my answer? That's not my answer. Remember, when you are looking for tan, do not forget you need to find the inverse, which is that -1. So when I hit second key tan, 1.1667, I get a theta now of 49.399 degrees, or 49.4. That is only one part of my answer. Part 2, you can SOHCAHTOA again, or you can Pythagorean. I'll go ahead and Pythagorean. A squared plus B squared equals C squared. Is this my C squared? Yeah, it's my hypotenuse. Or 1.2 squared plus 1.4 squared equals C squared. Please don't forget to square root at the end. I know it's time for us to leave, but I needed to go over this part. The problem is our homework number 4 is due on Tuesday. I don't think we're ready for homework number 4 yet because we haven't even got to 2 dimensionals with the 8 variables. So that's what we're going to do. We're going to do the back of homework number 3. So this is going to be homework number 3, part 2. That is what I'm going to put into D2L. I'm going to switch everything one day back. I'm going to move it back. So this is all you need to do. This is going to be due on Tuesday. 1 page. It's due on Tuesday. 1 page. You have a super awesome day. I don't know if you have another class. I apologize if I talked too long today. That's going to be Tuesday the 23rd. Have a super awesome day.